Alright, these are 9.3 double replacement practice problems. In a double replacement reaction, your final product is going to be a precipitate or water or gas. I don't know where the gas ones are. Gas. There you go. So that's what makes it a double replacement. If it doesn't produce one of those three things, it's not a double replacement reaction. As you can see, I'm using the applied math only because it has everything on it. And so if you're in general and checking out this video, then you'll just have to skip over the ones that don't apply to you. So in every double replacement reaction, there's going to be two aqueous solutions that come together to produce either a precipitate, gas, or water, and some other product that we really don't care about. So let's do this. Aqueous solutions of potassium iodide. K is a positive 1, I is a negative 1, so it makes a nice ionic, and that's aqueous, plus silver nitrate, Ag, and nitrate is NO3. NO3 has a negative 1. Silver is a transition, but it doesn't give me a Roman numeral, which means it's giving one electron away. So that's a nice ionic, and that's aqueous, and it forms the precipitate silver iodide, Ag. We carry the charge of Ag from this side over to this side, iodide, and then that's a precipitate, so that's a S plus. We have to take care of whatever is over here for conservation of matter. And I haven't used a K, and I haven't used an NO3, so K is plus 1, NO3 is negative 1, and that's aqueous, and so that's it. And then we would have to balance, and so no chart, no points, and so I have K equals 1, I equals 1, Ag equals 1, and NO3 equals 1. And on this side I have, start with my K. K, I, A, G, N, O, 3. K equals 1, I equals 1, A, G equals 1, and NO3 equals 1. So we have a balanced chemical equation. Aqueous solutions of ammonium chloride and sodium hydroxide are mixed. No precipitate forms and no gas is produced, which means it's not a double replacement. So I'm going to use no reaction to indicate that this is not double replacement. Aqueous solutions of aluminum chloride and sodium hydroxide are mixed, forming the precipitate aluminum hydroxide. So aluminum chloride, Al, that's a positive 3. This is a negative 1, so I'm going to need 3 Cls in order to satisfy aluminum, plus sodium hydroxide, which is Na, that has a charge of 1, and that has a charge of negative 1, so that's a nice ionic. Goes to forming the precipitate aluminum, Al, hydroxide, which is OH. I need 3 of these. I put it in parentheses to make sure that it doesn't look like I have 3 hydrogens, and that is the solid precipitate plus aluminum hydroxide, Al, wait, what? No, just kidding. And then I've used aluminum, so I must need Na and Cl. I always want to list the positive first, and that's going to be aqueous. So from here I need to balance Al, Cl, Na, and OH. I can keep together because I have an OH on this side and an OH on that side. And then I have Al, what's my time at, Ty?
4:10.
4:10?
Or 4:10, yeah.
Okay. Tell me when I get to 10.
10 minutes?
Yep. OH equals 1 equals 3 equals 1 equals 1 equals 1 equals 1 equals 1 equals 3. Alright, so I'm going to start here by putting a 3 in front of that. That changes that to 3. That changes an A to 3. Go to this side, put a 3 in front of here. That changes that to 3, and that changes OH to 3. So I should have 1, 3, 3, 1, 3, 3, 3, and that is balanced. Aqueous solutions of lithium sulfate and calcium nitrate are mixed, forming the precipitate calcium sulfate. So I've got lithium, which is a +1, and sulfate, which is, if I go to page 221, I think it's a -2. Sulfate, -2. Yep. -2, which means lithium is going to need 2, and this is SO4, and that's aqueous, plus Ca, and then nitrate is NO3. This is a -1, this is a +2, so I'm going to need 2 of these, forming the precipitate, oh, and that's aqueous, calcium sulfate, CaSO4, and that's a solid, plus whatever I didn't use yet. So lithium and NO3, and that's a -1, so that works. And now we balance LiSO4, CaNO3. I can keep all the polyatomics together because they're found on both sides. LiSO4, CaNO3 equals 2, equals 1, equals 1, equals 2, equals 1, equals 1, equals 1, equals 1. Alright, so I'm going to put a 2 in front of this, changing that to 2, changing that to 2, and I'm balanced. When the aqueous solutions of sodium carbonate and manganese 5 chloride are mixed, a precipitate forms. The precipitate is a compound containing manganese. So sodium carbonate, this is a +1. Carbonate is, it's okay. CO3 is carbonate. Where are you, carbonate? Carbonate is a -2. So Na2, CO3. And that's aqueous, plus manganese, which is Mn, and that has a charge of +5, so I need 5 chlorines, and that's aqueous, are mixed, and a precipitate forms containing manganese. So there's my positive, and there's my negative, so it's Mn, and this is a +5, and this is a -2, so I'm going to need 2 of these, CO3 parentheses, and I'm going to need 5 of those. We never want charges in this one. Alright, and that's our solid, and then pick up whoever's left behind. So Na and Cl, and that's aqueous. So now we balance. NaCO3, MnCl, NaCO3, MnCl equals 2, equals 1, equals 1, equals 5, equals 1, equals 5, equals 2, equals 1. All right, so I'm going to put, if I put a 5 here, that's not going to work out for me because that's at a 2, and 2 and 5 don't come together. Let's see, what else could I do? Okay, I'm going to start here and put a 5 here. That makes a 10. That makes 5. Okay, that's a 2. So that's a 10. So that's a 2. And then if I go 10, that's 10. That's 10. 5 and 2. 5, 2, 10. 5, 2, 10. Nope. So 2 won't go into 5, so I can't reduce it. That's as much as it is. All right, so that is double replacement, forming a precipitate.